Okay.
Thank
So
you.
everyone, this is method one, multiplication. We're going from top to bottom. And so I carried over, I multiplied the first three. And so again, in the last part, 34 times 2 plus 2 gets 70. And then 70 in base 60 is 1 comma 10. And so you write 1 comma 10 here, right? The important thing here is that you write it all in this same row. Because we're carrying over as we're multiplying our set, we don't need to write all these placeholders like in the second method, right? So this is what I mean by it's a little more streamlined. So now you do your next set of multipliers because you have your 3 out here. This is that second digit, right? Or that second place rather. And so what you do is you start with the placeholder and then you multiply again 3 times. You do your first 3 times 23 is 69. So you put 9 here and you carry over that group of 60, right? That one group of 60. Then you multiply 3 times 4, but you add that 1 that you carried over here at the way top, gives you 13. And then you do your last multiplication, 3 times 2, which is 6. And you write that at the far left here. And so the placeholder is important. At the end, you just add up your values and you get your solution bottom. Okay, this is method one. This is the one I would go with these sexagesimal multiplication problems. The important thing to notice here is that this is in sexagesimal. So I recommend method one with your sexagesimal multiplication problems. Now, if you wanted to do method two, well, you could. We didn't do it in class, but I went ahead and did it anyways to show us, and it would look something like this. Okay. So let's take a look at what's going on here. We got the same answer, just another path. So we do our first multiplication, 34 times 23, which gets us 13 comma 2. I converted it already. And what you do here, the difference is that you write the entire value here in that first row as is. So you write 13 comma 2, you don't carry anything over. You notice that? You just write it as is. And so then you would go to your next multiplication, 34 by 4, which is 2 comma 16. But remember that you put a placeholder because you're moving to the next one, right? So this is the second method, and this is how we would do it. You put a placeholder, then you write 2 comma 16 as is. Then you move to the next multiplier and put 2 placeholders, and you would do 34 by 2, which is 1 comma 8, all the way out here to the left. All right. And so then you have to do your next set of multiplication, which is with the 3 here. And I color coded those in blue so that we could see what's going on. In this case, you would start with the placeholder. All right. You would start with the placeholder because you're moving to the next number. And you would multiply the same way you did in the first 3. 3 by 23 is 1 comma 9. Write it all in that first row as is. 3 by 4 is 12. You don't have to carry anything over there, but you do have to write 2 placeholders before you write that. And then you write 3 placeholders, and then 3 times 2 is 6. So you write 6 here at the far left. Then all you have to do is add up all those values, top to bottom, and you should get the same exact answer. Okay. So 2 paths that lead to Rome, right? Same way. 2 ways to skin a cat. I shouldn't say that. I have a cat. But anyways, the same idea here. I don't know which method you prefer, but they both work. I just thought I'd show you what that looked like so that you can have some idea. So what do you guys think? Does this help clear up some of the misconceptions? Are we still confused?
Can you go over why you put a placeholder for the 1 comma 9?
So the only real reason I have, and the way I've kind of seen it done in other examples, is just because we're moving to that next position here. It's the reason why we would put a placeholder. So that's really the best answer I can give. If you didn't do it, then you would just have 9 here. If anyone has a better explanation for that, by all means. But yeah, it's just because we start our new set or our next set of multiplication parts. So someone
I think personally,
what makes it easier when seeing that is like remembering, like when you take like the little blocks and cubes and sticks versus like the full cube. I don't remember if you guys remember doing that in elementary math.
Nice.
Because like when I took math 210, we talked about bases and that's how we remembered it. And
Yeah.
so it made it easier when doing the multiplication of it to remember like how it's in 60 to the first. So that's equal to a stick opposed to ones. And then so you have to remember it in the place value that way. It gives you a more visual way for you to see it in relation to each other. That just helps for me.
Okay, good. Celine, yeah, I mean, again, these methods are similar to the ones we've learned. And there was that we use bases, right, to explain that. So that's a very good good reason. So again, there's two ways to do the same thing. I just think that when you're in sexagesimal notation with the commas and semicolons, I prefer to do this method up here, but you do have to keep track of your carrying over values. That I will say, if you don't keep track of them, if you miss one, your answer is going to change. But here, although it's more work, a better way to catch your mistakes, right? I would say. So maybe this method works for you. So this second method I showed us, but in cuneiform. That's what I did. So you'll see this in cuneiform, and this is a way I would recommend in cuneiform you do it, but it's up to you. All right. So that's what I have to say.
I have a question, please.
Mhm.
I add the first group first, 13, 2, 2, 16, 1, 8, and then I added to the result of the 1, 9, 12, and 6. So I got the same answer.
What method did you use? Are you talking about?
The second method,
Okay, so you
Yeah.
said you added.
when I multiply 34 times the first, the 2, 4, 23, and then 3 times the same digit, and the answer of the first like multiplication and the second one I added together. So I
It
got
worked.
the same answer.
Yeah. Yeah,
So
I
is
mean,
the
if that
both
works
group?
for you, then that's okay.
Okay.
But you have to write your answer in sexagesimal. That's the important part. Okay.
Okay.
So in the chat, would it be wrong if we converted to base 10 then to back to base 60? That's a good question. I did say that would be okay. Because you're doing some converting, which is practice. But I have to make sure that you guys get this practice in, but I will say that that's all right. You can convert to base 10, and then do the multiplication and convert back to base 60. You'll just find that converting back to base 60 with this one is a bitch because it's a long number, right? So just keep that in mind. It's not that difficult though if you know your powers are 60, but once you have them there. But yeah, you can go about it that way. So there's really more than two ways, right? There's several ways you can approach these problems. So, all right. Any other questions? Cool. All right, guys. So I'll grade the homework. I'll look over it this week, and I'm going to be posting the new homework assignment after class in the afternoon. So you'll get some more practice with Babylonian math and then some Egyptian mathematics as well. All right, and we'll get started with that. So just thought I'd touch base here with this problem. All right. So where did we leave off last time? I don't remember exactly where we left off. What were we talking about? Did I introduce the Egyptian symbols?
Yes.
Yeah,
you
you were just going to talk
offer.
about base placement and how it didn't really matter.
Okay, got it. So let's do that now. Oh man, I wish we were in class because this would be a lot, like showing these problems are going to be exciting, but I'll have to wait and show them to you next week as well. But we'll look at the start of it here. So let's see. So just to recap. So we have their symbology. So there's symbols. So let's take a look at some of the symbols. What were those symbols? Let's see. We had a rod, which equaled 1. we had an ox strap, which equaled 10. We have a coil of rope, which is 100. And then we have, what was the other one? This guy. We have a lotus flower, right? And that represents 1,000. And then we had this really janky looking finger. Wow, that does not look like a finger at all. It's like a potato. This represents 10,000. And then I believe there was a frog. Yes, it's as good as it gets. Which was, who remembers what the frog represented?
100,000.
100,000, good. And then what did we have after that?
The million symbol.
The million symbol, which was
The guy with the hands up,
Yeah.
kneeling.
waving his hands in the air like he just don't care. All right. Oh, wow. That is amazing. There we go. Something like that, right? Okay. So these are the symbols. And so let's practice doing some representation. Let's represent some of these. So let's get some practice here. Let's represent 324 in Egyptian. How would that look? Well, let's take a look. We have that a coil strap or a coil of rope represents 100. So we can write 3 of those. We have 20, so 2 10s for the arches, so 2 10s. And then a rod is 1, so we can write 1 2 3 4 like that. Right? You could also write it in reverse, and it would give you the same, it would mean the same thing. All right. Remember that position isn't important. As long as you have all of them there, and then you would get the same value. What about 201? How do we represent 201? That's a very good question. What do we notice about their symbols?
No zero.
No zero. So another issue, right? How do they represent 201 versus 21 or so on, or 210 for that matter? So this was an issue. And so it really came down to you adding these values and just correcting them, right? But to represent 201, you would just have 2 rods, or sorry, two coils of rope. So let's look at that. Would be, let's see, 200s, so 2 coils of rope. And then 1 rod, like that.
So when writing a number, do you have to keep the same symbols together? Like, because I know like the placement doesn't matter, but do the symbols being together matter?
Yeah, you group them together. So you put the symbols that match with each other grouped together. Mhm. Good. Let's try another one. Let's see. And then what do those represent? represent the first one in Egyptian and then tell me what the second one is. Okay, so 54, what would that be?
That'd be 5 of the ox straps and then 4 of the like bars.
5 ox straps and 4 rods, right?
Yeah.
Good. Okay. And what does this number represent down here? Did anyone get it in the chat? We have
20,507.
good 20,000. So we have 20,507. Good. How we doing? So far, so good. Okay,
Yes.
let's do a little bit of addition. So really, there's really not much to say about addition, but just so that we can get some extra practice here. So I'd like you to take add okay. What do we have? Let's see. I have 1, 2, 3, 4, 5, 6 coil straps here, and 1, 2, 3, 4 here. It's a total of 1,000, right? So I can take those and make 1 lotus flower, right? So we have, and so now I have 4 of these, and I'm sorry, I have, let's see, if I go to the ones, I go 1, 2, 3, 4, 5, 6, 7. So 7 here, and I have 3 here. So that makes 10. So that gives me an extra aux strap. So we can have 1, 2, 3, 4, 5. And then what's left over is the 2. So we get 2 rods there. Did we get that?
Yes.
Cool.
Yes.
All right. Sweet. Let's get to the fun stuff. All right. Let's do some multiplication. I'm going to start with this. Now we know what 12 times 12 is, right? We're okay with that. But let's do it the way they did it. And what I'm going to do is I'm going to write out the problem, and then you're going to think about it and see what happened. So 12 times 12 from the ancient Egyptians' perspective looked a little something like this.
That's way over 12.
And I'm not done. I'm not done. Which would then mean we add they give us 144. So think about what just happened. Wrap your minds around this and type in the chat what you think is going on, or let me know. Go in your minds. Mm-hmm. Interesting. Okay. So we got some people in the chat. So they doubled, is what you're saying, right? What's being doubled? And added. Okay. So you have some time to think about it. In this case, 12. All right. So let me show you the same problem. Someone have something? Let me show you the same problem in a more familiar way. And then it'll probably start to click. So 12 times 12, we would start with 12. Then we would double that. And then we would double that. Then we would get 8. And now we notice that we have these two values here that give me 12. And so what I do is I take these two values to get my answer here, 144. Voila. Okay. So this is the gist of what's happening. All right. And if you think about it, we're just multiplying by powers of 2, right? So it's really interesting how this worked. It's very fascinating to see that they could just use this method to calculate their products. And you could do this with any set of numbers. All right. It will always work, except we're going to keep practicing here. And so I showed you in symbols here in Egyptian. We looked at it in digits now. And so now we're going to practice. We're going to keep practicing some more. All right. Let's see what that will look like. So let's do another one. So let's do 14 times 8. Okay. All right, so we're going to do 14 times 80. And here's what we're going to keep in mind. You are going to operate on 80 to reach 14. So you operate on the second value to reach the first one. And this is the way I want you to do these problems when we work on them, okay? On the homework and all this. So you're going to operate with the second to get to the first, all right? Make sure you remember that and you keep it that way, all right? So let's take a look. We would start with one group of 80, then 2 gives me 160, then 4 gives me 320, then 8 gives me 640. What comes next?
I think we would just add the, no wait, to 14, that would be 8 plus 4, that's 13 plus 1 is 14.
So 8 plus 4 is
Plus
12.
Oh, plus 2 is,
Plus 6.
my bad.
So, no worries. You see that 8, this adds up to 14. And so what we do is we take these three values. To get our solution. Pretty cool, right? This is called the doubling and adding method. Now, the Egyptians didn't always follow the same structure. Sometimes they saw it more convenient to jump a couple digits, a couple groups. What do I mean by that? Well, let's do the same problem. We start with one group of 80. And rather than go all the way, we'll go to 2, they would jump down to 10, which gives them what? 800. Remember, what's the goal here?
To get to
To
14.
get 14.
To get 14, right? So what do we have here? We have 11. So let's go down to 2, because if we went to 20, what's the problem with that? Too much, right? So rather than go to 20, let's go back down to 2. And so 80 doubled is 160. And then from there, we can go to 4 to get our 320. And do we have it? Do you see it? There, right? And so you add. And you get your answer.
When using this method, would it be wrong instead of just like down to 4 if you just kept it with the 2, knowing that you add another one of 80 to it? Because another 1 plus that would have gone to 14 as well.
So you're saying, say we would go 1 to 10 to
Yeah.
to 2 and then another 2 is what you're saying?
No, another, because
Oh,
another 1 would be 14.
True. I actually haven't had that question before. That's a good question. I would say it's not wrong, but I'd like you to use the methods that we're practicing here in class. So
Okay.
stick with doubling and then this value of multiplier by 10, all right, which is what they would more commonly use. So if we
Okay.
want to keep it in spirit of the ancient Egyptians, we would do it this way. Technically, you could do 1 14 times, right? it would eventually get you to what you need, but I feel like that defeats the purpose here.
Okay.
Okay, so yeah, so stick to the methods we're practicing and then we'll see what other things we can think of. All right, how are we doing? How do we feel about this so far? All right,
I got a question, Professor.
yeah,
What if it was 80 times 14?
good question. What do you think, Sergio? It would still work, right? If you went through it. So if you did 80 times 14, how would that look? You would operate on what number?
14 to reach 280?
To reach 80, right? So it turns into maybe a more tedious problem. But remember that multiplication is what? We learned this in algebra, right? It's commutative, so you can do it backwards. You can do 3 times 2 or 2 times 3. It gets you the same result, right? But just remember that the way I put it up here for you to do is the way I want you to stick with. Make sense? So if I write it this way, you have to operate with the second to reach the first number, okay? And so I know that the other method does work as well, but I want you to stick to the way I have it written down. But if you want to do some extra practice, you can do it backwards and you'll see that it gives you the same thing.
I just had a quick question.
Yeah.
I'm not sure if it's like a silly question or if you already said something to like restrict it, but like, you know how like under the 14 you have 1, 10, 2, 4. Can you choose like any number to put there? Like for example, instead of you could do like 1, 10 and then 3 to get 14.
Yeah, but see, the thing is they wouldn't do that. So it's not common for the Egyptians to practice to write those values. They would, so the whole idea here is doubling. And I know that 10 isn't doubling technically, but it is one of the ways they would go about it in certain cases. I would say no. It's okay because it could work, but we're gonna stick to the ways that we're learning it here. Okay, so
Oh, okay, okay.
Yeah.
Okay, yeah, I think I just misunderstood the doubling slope. Okay, I see what you mean by that.
yeah. Let's try another one. Let's do. Uh, let's do that. So all together now, how are we going to approach this problem? What are we going to operate with?
We start with the two. Oh, go ahead.
Operate on, yeah, go ahead.
27.
You operate on 27 to reach 34. Okay, that's the way I want you to do these problems when you see them, okay? I know that it'll work the other way, but I want you to stick to the method that we're doing here. Okay. So there's a couple ways you can approach this. We've already seen that you could start with 2, or you could jump down to 10. I'll let you decide which one works a little more nicely. Find out, but
Could you do 2, then go down to 20?
you have to go through 10 first.
Okay.
Yeah. I want you to write down that step to get there.
Wait, so in a sense, we can make like 2 tables.
What do you mean, Alejandro?
Well, I was just thinking, right? Like maybe start at 2 so we can get 4 groups of that,
Mhm.
right? So we go from 2 to 4, right?
Mhm.
And then like on the other table, we can start at 10
Mhm.
since it's, easy.
Yeah.
And then we can go down to 20.
Mhm.
20 and 10 makes 30. And we already have the 4. Or do you want us just to,
Try to stick it all into one table. And
oh,
the
okay.
way I would write that, and you're on the right track, Alejandro. So I would say 1, oops. I would say 1, 27. Then I would say, let's see. Because remember, 34 is a large number, right? So in this case, for me, it makes more sense to go to 10 because I need to build 37. So then I would do 270. And then I would double that and get 20. So see, now I have 30 already. So I'm almost there. So it streamlines my work. If I were doubling, I'd be going 1, 2, 4, 16, 8. And yeah, eventually I'd get it, but it would just be a little longer of a process. But here I get 540. And then what do I have? Let's see, I have 20, I have 10, that's 30. I need 4, right? So if I need 4 in my mind, okay, I'm going down to 2 because that's where you need to start. So you need to write the 2. And that cuts it down into 54. And then I double that to get that 4. And that's what I was looking for. And 4 is 108. And so now I can see that this gives me 34. And then these values are going to add to give me 918, I believe. That's what we got. Like that. So it's a little bit of a combination of both, Alejandro, if you see it. So you were on the right track there. I would just, instead of doing 2 tables, put them into 1 and then see how it kind of comes together. It's almost like a game, right? You're trying to make that value come up in the first column. And so you just have to play around with it creatively. So yeah. Good stuff. All right. Did anyone do it a different way? Did anyone just double all the way through? No, no one doubled it? No one tried? Did it take forever? Yeah.
Well, you can get to, what is it, 32?
Uh-huh.
Kind of soon,
Okay.
and then you already have the 2,
Okay.
so- right?
Yeah, I believe so. I haven't done it doubling, so it would be 34. So that would be, let's see. So we would have 1, 27, 2, which is 54. And then we would get what? 4, 108, 8, which is 216, 16, which is 432. So then what do we have here? We got 16 plus 8 is 24. Then plus 4 is 28. 31. Right? And so we need 3, right? So it looks like if we went down to 32, that wouldn't help. Yeah, so do we reach a dead end here? Is that what we're looking at?
Well, 32 plus 2, wouldn't that equal 34?
Ah, there it is. Yeah. Ha, I got lost in the sauce. All right, so 32 and 2, right? There we go. So rather than looking for the other ones, whoops. Rather than looking for the other ones, I would just focus on the ones that worked here. And then what is 32? So it would be 864. Yeah. So you would add these two, 864 plus 54, and you get 918. Okay. So there you have it. Right? So I would accept either method or either set. Cool. All right. Great. How we doing? We still alive? Yeah. Okay. So, you know what? I don't think I want to continue with the next part because the next part that we're going to hit is division. And I really, really rather do that at the beginning of class when we start our next day. So I think we're going to stop here. We're going to stop here with multiplication. I'm going to give you some more practice in the assignment. You let me know if you need some help or you're struggling with it. How did we do today with multiplication? How do we feel about ancient Egyptian math so far?
Easier.
Good, easier.
Yeah, right. It's a lot more. Yeah, I knew you guys.
A little bit more manageable.
A lot more manageable. Yeah. Wait till we get to division. Yeah. So you'll see. All right. Good. So we'll put a pin in it here and wait for the assignment. I'll post it this afternoon. Reach out to me if you have any questions, and I'll stick around for another minute or two here if you guys have any last minute things to talk about. Okay. Yeah. All right, guys. So que tengan buenas tardes. Thank you for being here, guys. I'll see you next Monday in class, bright and early, 1, 2 o'clock. It's going to be wild. Let's see what happens. I'll send you guys an announcement over the weekend to remind you to show up to class. We're not going to be on Zoom. So make sure you have your masks and everything. And we're going to start the class day 1. The real fun starts then. All right, guys. Thanks for being here. Se cuidan. Take care.
Thank you.
Thank you.
Thank you.
Thank you.
Yeah, no problem.
Thank you. Gracias, profe. Have a good one.
You too. Gracias.
Gracias. Buen día.
Gracias. Igualmente. Bye, Jacqueline. All right.
Professor,
If anyone has a question, I can stick around.
I have a quick one.
Yeah.
Do you know if the Egyptians did like any like sort of calculus or any of that?
So they did a lot of the stuff that we're going to do is just with the fundamental operations, multiplication, division, and whatnot. But they did a lot with geometry. They never established like a formal system of calculus as we know it today. But they did things that kind of like implied that they were thinking about things in a calculus way. So I might touch on that. The Greeks really jumped into this kind of stuff. It's really interesting, but yeah, I wouldn't say that the ancient Egyptians did calculus per se. They just did things that were kind of in that kind of ballpark, but not quite there yet. Yeah.
Oh, okay.
Yeah.
Thank you.
Cool. All right, Alanda. Yeah, let's see. Who else has a question?
I have a quick question.
Hey, Jacqueline, what's up?
So, are you having office hours today?
I mean, I can stick around if you have a question or something on an assignment or anything. I'm not technically hosting, but I don't mind sticking around if you have some questions. Did you want to look over something? You're muted.
Yeah, if we can just go over a problem after, that'd be nice.
Yeah. Is it from Babylonian Math? Okay.
Yes.
For sure. So stick around. Let me get through these guys and see what they have. All right, Sasha, you just got added. Yes. So we had an assignment due today. I will send you an email explaining what that looks like, but it's on Canvas already. So you can jump into Canvas under Files. You'll see the homework assignment. It's homework 0. You'll do the problems there and the written assignment part. I'll give you till next Monday to turn it in. And if you have any questions on the work or anything like that, you can reach out to me. Now, my first 2 lectures, or the lectures from last week, are posted in a YouTube playlist through Canvas. If you look through my announcements, there's an announcement that says YouTube lecture playlist. Click on that announcement. You'll get a link that takes you to my videos, and you can click on the videos to look at the lectures or the meetings from last week, so you can make up or catch up on some of the work. All right, that'll help you get started on the assignment. And then just reach out to me if you have any questions. All right.
All right. Thank you.
Cool. Other questions? Williams?
Yeah, that was kind of just for me too, since I kind of got added late.
Yeah. Man, I don't know how it's going to work because next week we meet and I have like 48 students in this class. It's insane. So I hope there's enough seats. This is the one thing that worried me about adding more people, because I have to know how many seats are in a class. And, I added like 2 people. And now I'm concerned that we'll have to figure it out on Monday. But I have another section, this is the second section. Sorry, I have my 1 o'clock section. So yeah, we'll have to see how that works. But in terms of the work and everything, just like I told Sasha, go to the YouTube playlist if you want to see the lectures from the past week, and then work on the assignment. I'll give you till Monday to turn it in. And if you have any questions or need some help, just send me an email. I don't typically answer my emails over the weekend just because I kind of like to give myself a mental break. But Monday through Friday, I'll get back to you within 24 hours. All right. So just reach out to me if you need anything. Okay.
Perfect. Thank you.
Cool. Jeming, did you have a question for me? On once. Question? Nope. You just hanging out? Okay. I'll just assume you're chilling. All right, Jacqueline, what's up?
So, I had for 2B, I think it was. I just kind of want to go over that one because, like, I don't know. I don't think it's correct the way I did it.
Sure. Let's see. Let's see.
Because, I mean, we kind of have to master all of this, don't we?
Say again?
That we kind of have to master, like, all these, like, forms of math.
Yeah, I mean, we're going to get some more practice in the homework, then you're going to be tested on how to do these things. So, yeah. All right. So what example is it? Number 2B?
Yeah.
Okay, let me pull it up here on my side. Let me see if I can take a look. How'd you do with today's stuff?
Today's stuff was a lot easier.
Yeah, I know.
The Babylonian stuff, I honestly really struggled with it.
Okay. Yeah, usually Babylonian math and changing bases and everything is tricky for a lot of people. But let's see. Okay, so it looks like I'm missing something here. Okay, let me write it down. So on my screen. Let's see. So we have and then is this what is this what you're looking at? Is this the one that we're talking about?
Correct.
Okay, I don't know why. I thought I put something over here, but I guess I left it open. Huh. Okay. Anyways, so we're adding. So what, how did you start this problem? Oh, by the way,
So
let me stop the recording really quick because I know we're not recording.